Good morning and welcome to Simplifying Machine Maintenance Using Auto-Calibration. My name is Stephanie Price, Senior Applications Engineer here at Promess Incorporated. And subbing in for John Derry today is John Lytle.
Hi, John Lytle, Senior Application Engineer here at Promess. A couple of quick things is we'll have the chat panel on the right-hand side of the screen for the Q&A session that we're going to have at the end of this presentation, and included in that chat panel is our Pro CM16 flyer, which you can feel free to download, take a look at. That has a little more information on what we're going to be talking about today, which is our calibration meter.
So one of the first topics that we wanted to go over is just a little bit about machine maintenance and how the maintenance of an electromechanical assembly press, or EMAP as you will hear us refer to it, is different from that of your hydraulic press. With a hydraulic press, one of the things you have to worry about is verifying the oil levels, making sure the cleanliness, as well as worrying about wear items such as the coils on the valve assemblies, seals, pump assemblies.
Right, and kind of like what we're going to be talking about today, which is the calibration side of things. With a hydraulic press, it's difficult to calibrate them because you don't have that level of control you have with the servo press. Mm-hmm. But we're going to talk about the level of control we have to be able to do that. But then we're going to take it a step further and automate the whole process.
Right. With an EMAP, really, calibration is one of the only things you have to worry about. We do that basically on a yearly time frame is what we recommend, and then grease the press quarterly. It's pretty much all you have to do maintenance-wise on EMAP. So going back to calibration, right, because that's why we're really here and what we're here to talk about.
So basically calibrating or verifying, there are two different things. So I want to kind of clarify a little bit of this. So when we talk about calibration is where you're actually comparing the value of the integrated load cell on the system to a certified master load cell and then making an actual change to that measurement so that it matches that. That would be an official calibration, where a verification is where you're going to come down and compare the two readings. If they're within a tolerance, there is no reason to make an adjustment, and you go on with whatever it needs to do after that point. But basically, those are the two differences to it. So calibrating is actually making a change to the settings so that it reads correctly. Verifying is simply making a comparison between the two. We're going to talk a little bit about the traditional EMAP calibration. So traditional meaning a manual calibration. So that's basically adjusting the gain and the zero potentiometers to achieve the desired calibration results. So I'm going to kind of show you a traditional calibration and what we're talking about here versus what we'll talk about a little bit later, which is the auto-calibration.
Right. So one of the first things you can see on the screen is we have our Motion Pro software up, and we have the jog dialog. One of the first things that we need to do is jog down onto our certified load cell.
Before we do that, though, I would like to just explain a couple of things that we have here. So this is our 1 kilonewton press. This is our integrated load cell. This signal gets fed into our signal conditioner. The signal conditioner is where you're making these changes at manually. So there's potentiometers in here that I mentioned before. We're going to adjust those so that it matches the certified calibration meter where we have the load cell in line with the press. So like we just said, we're going to jog the press down. So you could jog that down now. Apply load to it. Oh, and it looks like you overloaded already. So you're going to want to back that off a little bit.
And this is what happens. It's not uncommon.
So what I would do is take that speed down to a slower speed. And I would extend down, and I'll tell you when you're getting close.
Yeah, I think we've just been a little bit off on our positions from the other day. So if you want to go ahead and move it down.
So, as you can see, we're extending out and
keep going.
Moving. Okay.
You got
Stop. Now adjust your speed to 0.1 millimeters. And then slowly jog down onto the load cell. So this is what we're doing here is the manual calibration way.
No.
And as you can see, it really requires a couple of people to do this type of operation.
So picture this inside of a plant. You have the PC that is outside of the station in the cell, and then you have to manually jog, then go in. You get there.
Getting really close.
Yeah. And what we're going is we're gonna try and get to
Good.
500 newtons is what we were looking for.
So you're at 100. Keep going, just tap it.
So right there.
And now you can see
That
we're going to compare the readings from the master load cell meter to the readings you see on the screen.
right.
So we are off.
Yeah. So our we're reading at 770 newtons right now, as opposed to the 646 that we see on our readout. So we just need to turn, and there. You're at 765.
So now I'm making my adjustments here. And getting close. So this is where human error plays a little bit into this.
Right. So we're reading 762, and you're at a little bit too far. As you can see, now picture this going on inside of the plant. Like I mentioned, we have to go back and forth between the two. And also, once you're done and you have this, you have to home the press, and you have to jog back down to it. And there
So
we go.
within about
766
couple of newtons.
and 762.
So now we would jog back off of that. So we'd retract off, and then we would do this in 4 locations and make adjustments until we're within a specified tolerance. So typical Promess systems, we get within 1% of its full range through 4 points of verification.
Mm-hmm.
So once this was completed, then we go through, and then we'd have to manually write down the values and then generate a calibration report after that. And that's typically how a manual calibration is done with really any type of system. But what we're going to what we really want to elaborate on is our new Pro CM16 that we can use auto-calibration with our Ultra Pro system. So let's move into that.
So first, for auto-calibration, you need to have the latest motion control software, which is the Ultra Pro software, along with the digital signal conditioner, which we refer to as a DSC, and then the Pro CM16, which is our calibration meter. The digital signal conditioner is the conditioner that our integrated load cell is already going to. So then you take the Pro CM16 and you connect it to that DSC through a USB cable. The nice thing is that now you can just go into your Ultra Pro software, create a calibration program, which is going to look very similar to what a production program might look like, only it has additional steps that allow for handshaking between the controller and the DSC to let it know to take the values from the Pro CM16 and do the check to see if it is within tolerance and make any adjustments as necessary. To go into a little bit more detail, we have a video that we're going to show you.
The auto-calibration has been added in the Ultra Pro software and features the same fully customizable programming structure as the standard Ultra Pro part programs. The user can determine how many points of verification are needed, as well as the force increments in which the verification is performed. The user can also choose how many force points the UltraPro takes into consideration when making an adjustment. The auto-calibration program will automatically generate a verification or calibration report that compares the verification points the user has defined to the user-defined tolerance. The reports are saved locally on the controller as a PDF and can be referenced or exported for future viewing. The Promess Pro CM16 calibration meter and load cell are required for auto-calibration. In this example, I have purposely adjusted the integrated load cell calibration to be far outside of our standard 1% tolerance. I am going to run a verification cycle, verifying this 1000 Newton press in increments of 100 Newtons, up to 900 Newtons. The report provides results of the press's integrated load cell versus the reference load cell. We can see here that this is far outside of the tolerance and we have a failing verification result. Click OK, and next we will run a calibration routine. The calibration cycle is similar to the verification cycle. However, once it is completed, it will prompt the user to make the recommended adjustment to the calibration. The calibration report provides feedback including recommended adjustments and allows the user to accept or decline the changes. I'm going to accept the changes and now run another verification cycle to see how the values have changed and how they compare to the tolerance. On this verification report, we can see that our error is well within the 1% limit, and our report shows a passing result now. If we want to look up a previous calibration or verification report, these can be found in the More Tools menu under Calibration Reports. This shows all of the past and failed verification cycles as well as the adjustments made. This can also be saved as a PDF or notes can be added for later.
So as you can see from that video, you get a much nicer report that's stored locally for you and a way that you can go back and view it. Also, because you're using a program, you can store that data on the UltraPro database and view it later using our data utility.
Yeah, and also it can be integrated into a more frequent process if you wanted to do that as well. We recommend once a year, but each facility that utilizes our presses and things like that kind of has their own schedule, but it's, as you can see, it's pretty easy to do. So once it's set up, at that point, it's just a matter of running the program. So you can integrate it into a more frequent routine if you wanted to, or things like that. The other thing it does is you can see when I was doing the manual calibration, there's a lot of human involvement there that can create error possibly. So that goes away because now you literally have the meter talking to the controller, and the controller can then make the decision on whether a change needs to be made, whether just to verify whether to actually calibrate or not. And that's all done through software. So it's basically making some type of linearization calculation to make the numbers match. And I have seen personally, as I compare the two out in the field and that we get better results. So you get higher accuracies and things like that because of that.
Which is perfect. That leads right into our question and answer period. And we already have a few questions coming in. The first one being, how accurate is the calibration?
Well, there is no set amount, but how it works, and as you've kind of seen from the video and what we've been talking about here, is you really kind of set your own tolerance and then you calibrate or verify to that tolerance. So like I said earlier, we shoot for better than 1% of the full press range. So you're going to be within plus or minus 1% of whatever the press range is along those multi-points that we're checking. So as long as you're within that, that's an acceptable calibration, and then that's going to translate into the accuracy of your reading. Now the calibration meter itself is that's set up and calibrated, at least here at Promess, with an outside house that's a certified A2LA or NIST, something like that, some type of ISO calibration procedure that it follows, and that is at a much higher level than what we calibrate the system to.
So one of the questions coming is do you have to adjust at multiple force levels? And you do not. You just get a nicer linearization when you use multiple force levels to calibrate.
There's two things you're concerned with when looking at force values or force readings on your sensor, and that is, what it reads at that particular point, and also whether that whole signal's linear or not. Because if it's not linear to some level, or whatever you define as that level to be, or whatever the manufacturer of the system defines it to be, could make you become aware that there's an issue with the load cell, or it's been damaged, or in some cases they have been overloaded too much and they are no longer linear, and then it needs to be replaced and that type of thing. So it does more than just tell you that you're reading right. It also tells you if it's actually not damaged or things like that. So
someone was asking if this works with Motion Pro, and we did mention before, you do need to have our Ultra Pro motion controller in order to use the auto calibration feature. How accurate below 1 Newton meter drag torque for calibration?
How accurate below 1 Newton meter for? Yeah, that depends on the torque system and the torque sensor that you're using, really. Right. Basically, like I'll go back to what I said about accuracy in calibration, and that basically boils down to better than 1%. So if you have a sensor that is much larger, then it'll be tough to get down below 1 Newton meter. So hopefully that kind of answers that question. It all goes back to the percentage of the range that you're using and how finite you can make those adjustments.
Right. If you're talking about 1 Newton meter on a 5 Newton meter torque pro, then it should be pretty good. If you're looking at a 50 Newton meter torque pro, it might be a little bit more difficult.
Right.
How often should you calibrate? I think we covered this just a bit ago. We suggest yearly, but everybody has their own specifications for that. So
yeah, you can calibrate honestly as much as you want. So there is no limit to how many times you can calibrate.
Is it necessary or recommended to verify or calibrate position readings?
That's a good question. So since we kind of focused on the EMAP servo press, position feedback comes from the servo motor of the system. And that's a digital signal, meaning that there is no adjustment for it. It basically uses an encoder or resolver, and those are pretty absolute signals. And as long as you are scaled correctly with the initial setup of the system, there's no reason it shouldn't ever read differently because of it being a digital signal. So on a digital signal like an encoder or a resolver, the only thing I would recommend is just a verify that it's reading right. And then if it isn't reading right, there is no adjustment you can make. At that point, there's something wrong with the system. So the servo motor encoder needs to be replaced, or a setting was changed or something like that. Now, if your system is using some type of analog sensor for position readings, then yes, there is some calibration that goes along with that. And basically what we would do is we'd have some type of verified position measurement device. Typically that's a gauge block or something like that. You put that into the system and then do the same process that we kind of showed here manually or automatically if it's a controller that's capable of doing that.
So can you use a non-Promess load cell? So you can use an external load cell if it's being taken into the system and integrated through the digital signal conditioner.
So if I understand that right, you're right. If we're talking manually, then any load cell can be calibrated with any other load cell, and in order for it to be accurate or the correct way to do it, one of the load cells that you're using to measure the load cell in production has to be certified. If you're talking about auto-calibration, then yeah, it has to be part of the closed loop system. Mm-hmm. And that's basically what Stephanie in that video was talking about, is it's integrated into the whole process. And that signal needs to be fed back into the controller so the controller can then make adjustments if needed to do that. So yes and no. As long as it's part of the system, yes, it can be done. And our external load cells are not necessarily Promess load cells. Sometimes we use external load cells from other manufacturers and things like that. So,
and other customers use their own as well.
Right, exactly.
It looks like we do not have any other questions. So I just want to take some time and thank you for coming out or watching us today. If you are interested, we have our next webinar, which will be in conjunction with SME Magazine, and it's Prototype to Production, where we're going to actually walk you through our process development center. So it's really nice.
Yeah, that'll be an interesting one, because that kind of shows you the whole process of taking an application that somebody has or somebody thinks about, dreams up, and then turning it into a real piece of equipment that can actually do that application. So that'll be fun.
So if you'd like to register for that, the link is in the chat on the right-hand side of your screen. There's also a link to previous webinars that we have done. And if you would like us to come out and calibrate your Promess system, feel free to contact us at 810-229-9334.
Right. So real quick before we finish, I'm glad you touched on that, because we offer that service. Our application team's capable of doing that. We have certified equipment that we use. We can do both the auto and the manual. Or if you're a very self-sufficient type of company or something like that, you can purchase the auto calibration equipment from us directly here and do that yourself on your own time frame or whatever you have at your facility. So thanks again. We'll talk to you next time.
Have a good day.